Hello everyone. In this video, we are going to see a research paper on big data storage technologies. The contents covered are overview of the paper, introduction, objectives, distinguishing between different storage technologies, then contemporary technologies, taxonomy, and future challenges in the storage systems. So this paper provides us the overview that storage is a primary thing for big data analytics in the real world applications such as scientific experimentations, healthcare, social networks, and e-business. So the primary objective is this paper is to conduct a comprehensive investigation of state of art storage technologies available for the big data. Then, in the existing approaches are compared with the Brewer's gap theorem in order to evaluate the performance of the storage technologies. Then, the significance and applications of the storage technologies has been discussed, and also some future research challenges are also highlighted in this paper. So, the big data is nothing but the increasing amount of data that has been gathered from various sources. So relational database is more efficient in terms of accessing, storing, and retrieving from many decades. This paper highlights the features of distributed databases technologies available for big data and represents a more comprehensive review. Authors have thoroughly studied 26 NoSQL databases in this survey and investigated their performances. Objectives of this paper is to investigate the different storage structures of a wide range of technologies in big data environment, to highlight distinctive properties of each storage technology, to develop a taxonomy and evaluate big data storage technologies according to well-known Brewer theorem represented for distributed systems, then to identify the challenges and research directions for storage with the big data storage in the future. So in this paper, they have discussed the SWOT analysis of relational databases and big data storage system. So this analysis is based on strength, weakness, opportunities, and threats. So in traditional database systems, support highly structured data storage. Then specialized data manipulation languages are also available. Then a specialized schema is also possible in this traditional database systems, whereas in big data storage system, heterogeneous structured data support is available and simultaneous accessibility that in accessing can be done at a time by the different sources or by the different ways. Then weakness are in traditional database systems, performance bottleneck, then processing delays increased, deadlocks with the growth of data, limited storage and processing capacity, then no compliance with ACID due to its scalability and performance. So the big data storage system has no compliance with the ACID properties, that is atomicity, consistency, isolation, and durability. So they have a smooth running with that. Then opportunities in traditional database systems, they provide support for complex queries. Atomicity in is complex transactions, built-in deployment support. Then in big storage systems, improved query response times and simplicity in storage structures, data intensives are the opportunities available. Then the traditional database systems, extensive volume of data for storage with dynamic growth is one of the threat. Then complex data structures can also be a drawback here. Then frequent input output needs, real-time processing needs are all the threats of this traditional systems. Then in big data storage system, large number of small files, deployment may need the community support are the two threats. So the contemporary technologies discussed in the paper is about Hadoop distributed file system, which is an inspiration from the GFS, that is Google File System. So the Hadoop distributed file system is suitable for the solution for data intensive applications which require gigabyte to terabyte scales. They require a very high throughput. So HDFS has a namespace separated architecture. So we can see here we have taken the example of a GFS, that is Google File System, where metadata is stored on the master node and which is called as a name node, and whereas the block split files are located on number of data nodes here. The block operations are stored in here data nodes. Then the name node performs mapping of the data on data nodes and namespace operations such as open, close, and renaming the file. And the data nodes will provide us the read write request and create the blocks, that is data blocks and their replicas. Taxonomy of big data storage technologies. So there are four data type databases model. Those are key value, column oriented, document oriented, and graph databases. Whereas in licensing, we have three categories, that is open source, proprietary, and commercial. So the representation of key value is being shown here, which has a row ID and it's filled with all the rows are filled with the keys here. Then the key value database provides support to a very large volume data storage and current query operations also. Offers less memory consumption and the flexibility of adding more records is easily available, and it's very useful for us to add new records, and it's easy to add also. And applications of the key value storage databases are online games, online shopping, and other web applications where an enormous number of small size records has to be managed. So in column oriented database system, um, we know this type of NoSQL system is suitable for vertically partitioned, contiguous stored and compressed storage systems. Here, the data has been partitioned in a vertical manner where we store the attributes vertically. We store each attribute vertically, and this makes accessing the data very easy. The application areas of this column-oriented databases are data warehousing, patient data management, library systems, and customer record analysis. Then the data reads and retrieval of the attributes in such system is a quite fast and comparatively less expensive, as only the relevant column will be accessed and the concurrent process execution is performed for each column. So there is no extra waste of time, and also extra expensive is not at all considered here, as only a particular column is being accessed for a time being. For only the required column can be accessed using this column oriented database. The document oriented databases is similar to the key value structured database. Here in document oriented database, the data is stored in the form of key and value only, but they are referred as a document. So they support more complex queries and hierarchical relationships. They extract the metadata for further optimization and store it as a document. So the metadata here is more and more informations about the available data in a very different way and various aspects. So to provide, they extract the informations of the available data only in a different aspects. That's what is metadata here means. So use cases for document-oriented databases include social networks, analysis of website, and complex transactional data applications. So the graph databases are used for complex business processes and interconnected data as it is a relational data structure offers easy data traversal. So highly frequent trading systems and recommendation system prefer graph database to achieve a low latencies. So graph database system as a basic graph, it contains a nodes and a tree structure, and we can traverse through it by using different algorithms. So the future research challenges, according to this paper, are frequent data updates and schema changes. If there is any data changing frequently, so the schema also have to change. So this might be a challenge in the storage systems. And partitioning method, the way the storage is being partitioned for increasing increasing data, then replication factor, then user expertise, how to expertise and how to make the user experience more efficient and convincing. So the overall conclusion of this paper is that mainly, this paper is focusing on categorization under data models, classifies modern storage technologies for big data as a key value, column-oriented, document-oriented, and graph systems. Future key challenges in storing big data are also emphasized in the discussion. And in conclusion, it can be stated that systems are inclined towards provisioning consistency and availability as required by the users. Thank you for watching this video. Please do like